Hello everyone, and welcome back to another video series or video to this video series for the correction. Today we're going to be talking about the Spyder IDE. You should have installed this during the installation videos that were discussed earlier, and we're going to start from the beginning. I'm going to talk about how to get it to run using the command prompt. Also go over the basics of the interface, as well as give you guidelines on how to create a project and make sure that your folders and where you're saving your data and how you can access your data and stuff like that. You just have the general overview. This is nowhere near a full detailed Spyder video, but what I want to do is make sure that out of the box you understand the basics to getting started. And honestly, if you're in one of my workshops in the class, we'll go through the further details during those situations. But as of today, I want to make sure that you're ready to run, ready to go and go forward using the Spyder IDE. I got a feeling when I make more of these videos, I will probably be utilizing that IDE more than I'll be utilizing the Jupyter IDE, just because it's one of my favorite IDEs, especially if I'm not doing remote programming. And that IDE Spyder is very similar to the R Studios IDE. So if you're familiar with R or R Studios, it would be a good IDE. It'll be an easy transition between that IDE to this IDE because they have a very similar setup. All right, so let's get started and go forward. All right, step one. First, you have to get the IDE running. And you remember in the last video we installed Miniconda and Conda, and I talked about the Miniconda command prompt. I'm gonna go and click it first, so that'll put us here. If you don't want to use the command prompt, you will have to go and navigate to this folder that I talked about in the other video, and because this is where the Conda commands actually work in Windows. All right, first you need to look at your environments. I think I have a few environments. So if you type in conda info --envs, it'll show you all the environments that are currently located onto your machine. So currently I have 4. I'm in my base environment, which is like in general if I use this environment, it's like the base for all environments. But then I have 2 created environments, one that's called Spyder and the one called class. For you, I would create an environment. If you're a student, I will create an environment for every class that you're in, because the dependencies and the packages that you might need for that course could be completely different from a different course. And it's common practice to have environments either based on your course you're in, or in the real world, environments based on the projects you're working on. So if I'm working on this, neural network project, or I'm working on this project to predict housing prices, I'm thinking about some machine learning type project, but I will have an environment that represents that entire, represents the data and stuff for that entire project. And we'll use that kind of structure here as well. So what I'm going to do for this training, I'm going to get into my Spyder environment because it has all the packages that I know that I need just for tutorials. But for you, I would go into the environment that you've created for this course. So to activate that environment, I type in conda activate Spyder-env. That put me into the Spyder environment, which is, if I were to do conda info again, you'll see that I'm not in the base anymore. I'm actually in my Spyder environment, and Spyder is in here, which is in here as well. So now you should just be able to type the keyword Spyder and press enter. And if you've installed everything like before, Spyder should just boot up. Again, to get to this point, you have to watch the installing IDE video. Let me close this out. All right. So once you get into this environment Spyder as well as Jupyter are called IDEs, which are integrated development environments. In general, what that means is that each one of these quads could be their own thing, right? You have a text editor on the left. This text editor is no different from typing in Notepad. On the right, you have the console window, which is like a terminal window on a Linux machine, but this is kind of like your command prompt window that actually is where the commands are called to initiate actions in to initiate actions in Python to cause it to actually do something. So even when you're in the editor, when I run, or say I hit the run command or run this line command, all it's doing is doing that run inside the console window. So technically you could type in the console window and do all your run commands. We'll talk about this when we dive into looking at different data types for Python. But you can work here or you can work here. The good thing about working on this side in the editor, you can actually save what you did, name the files and so what, and you can reproduce it. I can open it later and rerun the code that I had put down here and get the environment back to where it were. Where if you worked in this environment, you won't be able to do that. Once you leave, it's over. So that's the reasons why having a connected integrated environment works. And the biggest thing that I like about any type of IDE is the ability to see your variables in real time. So when you are saving, creating variables, conducting different analysis, sometimes you want to know what you thought was what was in that variable, or the data that was in it. Was it a matrix? Was it an array? Was it a string? You can easily see all that information in this area, which is called the Environment Explorer area. So this area is made up of 4 windows. The first window, when it boots up, is the help window. So if you try to run help commands to try to figure out what certain things do, the results of those commands will show up in the help command, and you'll see you have the help command, you have the variable explorer, the plot, and the file. So if I click on the variable explorer, now this will show me all the different variables if I created. So for instance, I'm not talking about, if I had a variable that says A is equal to Michael Hamilton, and if I go up here and hit this little I here, means run something on a certain line. So wherever the cursor is, if I press this, it'll run that line of code. So once I press this, that would be the same as me typing in here doing this. So you notice that that line shows up down here, right? So what it done, it took what I had here, moved it here, and pressed enter. So if I had a B, say if I had, I can work here. B is equal to dog. Just making up random stuff. I press enter. 2 things you notice, right? It lets me know that the variable that was created is in the working section. It's in memory. It's a string, and that's what the values are. But you'll notice it's not on this side. It's not on this side because I didn't put it here. So if I were to close this out, save this and close this out, I would have this here, but I wouldn't have dog. So I'll have to recreate dog. So I tend to create all my code on this side. Dog B is equal to dog, right? If this ever closed out, to close out what's in memory, if you click the little trash can and hit yes, little trash can here, hit yes, it'll remove what's in memory. So those variables are not there no more, but that's cool. I can highlight both of these, press the little I, and both are back. So this is the value of the text editor, that you can actually write stuff in it, save it, and then come back to it. And it's integrated in the sense that if I have like things that can't happen, say if I put a SS, it'll give you information. It'll say, oh, there's invalid syntax in the code. So it'll let you know, oh, something is wrong here. I remove that, this little thing goes away. So it'll give you information about the kind of bugs that you're getting while you're programming. And that's very important reasons why you like IDEs. All right, so we got that in. We talked about the dog down here. All right, another thing. The next one is the plots. So the most common plotting tools that we're going to use is in these tutorials, they either be Matplotlib or Seaborn. Each one will have kind of like their own video in the future. But any plots you create will show up in this area. And then this area is going to show you all the files on all the files that are in your working directory. So you might ask, what's a working directory? A working directory is the directory in which you're currently pointing to. So for instance, right now, my working directory is the C drive, users, and mic. So if I were to like try to import data, or if I were to save a file now, it's going to get saved into this working directory. It's pretty much my profiles working directory. That's not very common on how I tend to work on projects. So what I tend to do, I will create a directory for the project. This is like step one. You open up Spyder, especially when you open up Spyder, you would do this. You open up Spyder, first you need to determine a working directory. So for these tutorials, I'm gonna go ahead and create something. Go back to my desktop. I'm gonna say a new folder, and I'm gonna call this folder Pi tutorials. And this is for me, so I use this same working directory when I talk about Spyder on my videos. So I know this is empty, right? This is where I want all my files to go. So what I would do, I would go back to Spyder, just make it back big, and now I will get the working directory to point to that folder. So now you got to go pick that folder. So if I go here, I know that folder is on my desktop. So you got to navigate to your desktop. Here's my desktop, and there it is, Pi tutorial. So you just select the folder. If you click it, there's nothing in it. You need to actually select the folder itself. Select that folder, and then now when you go here to look at files, there's no files, right? No files here, but we're going to save a file there. What I want to do is show you just how to save a file. So right now we're working into this this untitled 0.py. This means that it's not saved, so I want to save it into that folder. So I'm gonna go save, and then I'm gonna go pick that folder as well, same folder, desktop, Pi, and then I'm gonna save it. So these are gonna save as .py files. All Python files are .py, like Python. So you don't have to put .py here like it does, but it's going to save it naturally as a .py file. So I'm gonna call this main. Maybe it's my main script. So if I hit save, and if I were to navigate to that folder location, desktop, Pi tutorials here, and you'll see that's in that folder. All right, so we know now, and now this will be every time I hit save. Now you see here, now it says main, right? And it knows that the main file is in users mic OneDrive desktop Pi tutorial. That's the same, and then this is pointing to that same folder. So now this means that when I save something from the editor, it's going to automatically save in this folder. You see it shows that one file is here. That's this file. You can double click this file. It's already open, but you can double click it here to open it as well. So if other files were here, CSV files, you can double click and actually see what they are under the files window. What else I want to talk about? Okay, so the IDE. All right, so let's talk about the Explorer per se. So in the Explorer, as you saw earlier, it'll show you the variable names that you have. Let's create some more. I'll just give you a list of things. So these are just base types, right? Say if C was equal to 1, D was equal to 2, and then say we just look at CD E is equal to a list. You might not know what that is yet, but we'll talk about that in the future. All right, so if I run these three, you see you have the A is a string type. There's many types, in Python. You got strings, ints, floats, lists, tuples, dictionaries. So this is the type of data it is, the type of data container it is. This tells you how big it is. So this is a string. It has 16 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This one has 3 characters. The size is 1 because an int is only going to have one number. Even if it's 160, it's still just 1. And then you have a list of 5. So a list is kind of like a bag. So there's 5 items in the bag, and that bag is made up of 1, 2, 3, 4, and 5. So that's kind of how lists work. And if you double click on these, it'll pull up more windows just specific about this, just in case you might want that up, and you might want to look at this one. I forgot you can't pull up that one. because they're just values. But anything like these you can pull up that are lists, dictionaries, any other more complex container types, you can pull up and look at the different stuff. What else? Again, you need to know how to run commands. So I showed you how to run it line by line. So this command here runs wherever you are. So if I'm here and I hit that number, it's going to run that line. Now it also will show you the shortcut. So for me, control return is the shortcut for me. I set this shortcut up as well. I don't think it's control return by default. I'll show you where you can change those. So when I press control enter, it also runs D. So it's up to you to figure out how you want to do this. Now if you just want it to run, I think that's just F5. F5 will run the entire file. So say I didn't want to do it line by line. If I erased everything in memory and I pressed F5, that runs the entire project. You see how it says at the bottom, run file? So it ran the entire file. This is the line of code it does to run that script with that working directory. Another way to, let me make sure, I'm not sure what it is by default, but that's a way to run everything. I use this one the most, run line, because with run line, I can say it just runs what's highlighted as well. So say if I just wanted the last two items, I grab these and run that, and then there we go. I have the last two items I want, and I want the whole system. Again, this is personal preference. It's up to you how you want to navigate, but just let you know this is what's required to run some code. That one will run the entire line. All the other stuff up here, this is used for like the debugging tool, but I'm not going to go over debugging in this video. Save a new file. So if you want to create another file, you just hit new file and it'll create it here, but it won't be saved. So you'll have to save it and in that folder and do stuff like that. Now the good thing is, because you've already told it to save here, it knows that this new file is going to be in that location. You see how it says untitled 1 Python? It's not saved yet, so it's not showing up here. But if I were to hit the save button and just leave the name, it's going to pop it up and it'll tell you where you have to save it at. So I can say, I don't know, second file. I call it task 1, just in case we had some task we was running. That was going to be controlled by that file. All right, so now I said that is task 1, right? So what I need to do now, I'm pulling this up, bringing it over here so y'all can see it. So I went to that folder and I see that task 1 is now saved in that same folder on my other screen. All right, so that's how you would save a file. The same, all the other stuff is very similar to what you would have on Windows computing. So how you comment your code, you can search. The same thing on this top bar is under the debug, under the run bar. So that's how you run the file. Shift return, run cell in advance, run last cell, rerun last cell, alt return. So like these are just a lot of standard debugging and console style scripts. Another thing here, if you go to tools and you go to preferences, you can go to keyboard shortcuts and you can change these yourself. So for instance, like forgot the one about, I think it's control return is what I do. Control return runs selected, right? So this runs what I want it to be, whatever I have selected. But the thing is, I can change this to what I want it to be. Say if I click on it and I want it to be shift return. So, oh my bad. double click on it to bring this up, and then you'll press the command you want it to be. So I want it to be, instead of control return, I want it to be shift return. And what it does, it says run cells and advance. It's telling you that you're going to overwrite this, which is fine for me. So if you okay with that, you click the little drop down here, right where OK was. You click that little dot I think that was there, and it will automatically change it. But it removed this one, and honestly I'm glad it did that. I don't tend to use that that much anyway. So if I hit apply, okay, now if I go back to say main here, remember earlier I told you it was control, but now it's shift return. When I press shift return, it does the one line at a time. So again, that window, you can go and change all the different shortcuts by default in Spyder and move forward from that point. What else? Go back up here, consoles. This is your kernel. So your kernel is kind of the address in which where your Python is being executed. So you can restart it. I mean, this might not make a lot of sense if you're just getting started, but sometimes you need to restart your kernel if you like import some packages and they need to restart. There's an installation that has to happen when it first boots up that didn't happen when you just imported it. You might need to restart the kernel. So if you go over here and hit restart, click the little hamburger patty thing, hit restart. You can say restart the kernel, and what it's doing, it's restarting your Python environment. And what it does, it clears out your variables too, because when you it doesn't, it has to restart it completely from scratch. So make sure when you restart this, you've saved what you need to save, and you are okay with doing that, because you might have to rerun some things to get your variables back. All right, so that's very common though. You can start a new project. I'm looking at these just to see if there's anything I should talk about in this video. You can change your window layouts and stuff. I think I'm in the default, but there's other layouts. You have the RStudios layout. So for instance, this is the default, right? That's what I have. What if I want it to be like RStudios? Yep, and this is the RStudios layout, which means that the file structure and stuff are down here at the bottom. Like you have your variables, plots, and histories here at the top now, because that's how RStudios does it. Your file structure is down at the bottom, so file and help is down here, and then the command window is on this side. I actually like this view. It's fun. I haven't been using this, but this view is very similar. Like it's identical to RStudios. Why I've always said that it'll make it easier for you to work with Spyder because of that. And then you have other options: horizontal split, vertical splits, and so forth. So if there's other ways you would like to do this, you can do that as well. Let's see. I'm gonna leave it like this. Talked about that. If you want to close out something, all you gotta do is just click the little things. If I close it all the way out, right now, if you close it all the way out, it's gonna keep creating this like untitled ones. You can't have it nothing. But if you want it back, all you got to do, either go to open recent. That will open up anything I've recently closed. There's a whole bunch of simulations I have. Or just open it. You click that, it knows it's in this file, so just go in and double click it and it should come back. So if you saved it, you should be good. Make sure to save. Do not leave without saving. Your IDE will try to notice if you ain't auto saved, so it'll try to save it. But I've had many situations where students or people say they did all this work in a script here, and then when they left to come back, all of it was gone. And the number one reason is that you're not saving as you go. Spyder do not auto save as you go. You have to do that. Now that is a big difference between Jupyter labs and notebooks. They auto save, especially Jupyter labs, the environment. So it makes sure that you get a constant save as you go. I'm sure you can turn that on in Spyder. I'm just not sure how you do it. I've never really needed to do that. But yes, I think you're ready to go. Again, Let's go back to the view it was. I don't want to confuse anyone. Spyder default, and you can always flip those. So this is the Spyder default view. So again, this is just a quick intro to it. I will make other videos going deeper into in those other videos. I will be using Spyder when I go deeper into other topics like data types, the individual containers, how to like use those and stuff. I will use Spyder, and that'll give you kind of some practice of how to work with Spyder, how I use it, and how you can actually use it to do your data data analysis or create your software. Again, I am going to create a video about Jupyter Labs. It's gonna be a little, I don't use it as a regular day-to-day tool, but I want to give you the overview of it because you can use it for this class or your projects, and it's really good to use when you're working on a team that works on like remote servers. So for instance, in just talking in general, when you're working on big teams, they tend to use HPCs, high performance computers. But to get on an HPC, you have to kind of remote into them, which means that you have to have a terminal that you can password, username, and you can actually get onto those terminals. A lot of times when they do programming, they use IDEs that can be hosted on in web environments, like a client server environment. They actually can be hosted like that, and that's where Jupyter to me wins in that battle, because it can be hosted. Everything can be kind of web based, and it's all connected. It's easy to work when you're working from a remote location versus having to install Spyder on your actual computer and then remote and connect in and communicate. That's not very efficient when you're working with HPCs. So a lot of times you don't know about those technologies and how they work well when you're in school, because you tend to use things that are locally stored. So I just want you to be aware of that IDE. Its power, it has a lot more capability in general than Spyder does, and I really like how it formats things. Again, we'll talk about it a little bit more either in class, or I create videos to go into that in detail. All right, well, that's the end of this tutorial. If you have any questions, please email me either on my school email address or my Hamilton Digital Studios address, which is located on the website. And have fun programming. Talk to you next time.